test, turn yours on again, Andrew? Because this one's...
All right, I think mine's on now. Better? Perfect. Bueller?
There's no... It's like an hour of this while you're fighting off that food coma from lunch. I realize that our job in sustainability is essentially to prepare us for a better future. And I realize that I'd rather give us Star Trek than Mad Max. That's basically the future that I'm fighting for, and I think you are as well. So that's why I put myself in this position of spokesperson. But there's a huge problem with that, in that I do have weird tendencies. I have some weird habits, which I'm going to share some with you. First of all, look at me. I look like a friggin' dinosaur. I've got giant head and short arms. So physically, it looks bad on stage. And then I have weird hobbies. Like I have thousands of pictures like this. I'm not kidding. I collect them. They're just, they just bother me, and I take pictures of them. I don't fix them. I just take pictures of them. I also have other weird hobbies. Those of you that know me and are friends with me on Facebook know that I take pictures of old white guys lining up too early at airports. That's the thing that I do. I actually have a picture of Mike Hess lining up too early at an airport. So there's that. You can get it on Tumblr. I'm not making this up either. I took some on the way here, actually. There's a lot. It's a weird thing they do. They have to be in first in line like this and get in the way of wheelchairs. It bugs me. What else do? I peel the labels off everything in the house because I like the form of the bottle better, and it drives my wife nuts. Like, she hates this, apparently. I don't know. I wasn't listening. But also, torturing my wife is a huge pastime of mine. Just any way that I can make her life miserable is kind of a good thing. And when she takes me, she doesn't take me out anymore because I keep doing weird things like this. And, and she keeps complaining about my sculptures around the house. So, I'm a weird guy, and if I call you and I get your voicemail, I'm going to push star and try to guess your password. That's basically what I'm going to do. So if your password is like 1234, I'm totally changing your outgoing message to something awful, just to warn you. So be warned. What else do I do? This is my sister-in-law, and she is what I call the worst person on earth. I don't know if you have a sister-in-law like this. She's always, look what I bought, meh, and I hate her so much. And so she'll post things like this, and I'll just put, you're going to die alone, just like mean stuff. She unfriended me, actually, because of it. And then this was our office Christmas card this year. You see what I'm saying? Like, I shouldn't be in front of anybody, but yet here I am. So it's crazy. I'm dealing with this. I'm working through it. I'm talking to counselors and stuff. But I've been doing this now for 25 years, talking to people. And it's been a strange journey. 5 years ago, I made a conscientious shift to focus on nonprofit stuff. And so for 2 years, I was VP at the Living Future Institute, so I was thrilled to see the DPR office going for net zero certification, of course. Those of you that are not familiar, essentially what Living Future does that's amazing is they tell us where the bar is. They basically say, if you want to build a building, it has to generate all of its own energy, grow its own food, process its own waste, collect its own water, and avoid all known cancer-causing chemicals. That's the bar. And when it first came out 10 years ago, people told us it was impossible. And now there's dozens of buildings, I mean not hundreds, but dozens of buildings that have done this, and hundreds more that are planning to. So that's kind of amazing. It also changes that paradigm where we cross that x-axis from buildings being less bad to buildings being good, which is also interesting, because how many meetings have you been in where you're, oh, this is 5% recycled content. You're supposed to get happy about it. It's hard to do that, but here we're able to actually look at positive regeneration in a real way, because this little device is known affectionately as the tree hugger. And it does in 30 seconds what it used to take 50 men an hour to do. It's kind of amazing. It's a marvel of engineering. I mean, if you just step back and turn off your empathy, it's really a marvel of engineering in what it can do. But I thought, why can't we have the same ingenuity to creation as we do to destruction? Why can't we have the same opportunity to saving trees as we do to destroying them? In fact, this little device reminded me of this one from our childhood. Do you remember this one? It's kind of eerie how close it is. So I'm going to tell you about today a weird story, and unlike a lot of stories, this one's actually true. It's a true story. And it involves a nonprofit called the X Prize Foundation. And some of you might remember the X Prize from about 12 years ago. They had a competition for a spaceship. Do you remember this, vaguely? You remember hearing about it? And the prize was simple. It said, launch 3 human beings 60 miles up in the air, have them return safely, and do it 2 weeks later. If you do that, you win $10 million. Now, it took 6 years before a team actually won. In fact, several teams worked on this, investing about $100 million in pursuit of that $10 million prize. But eventually, a team won. That's Burt Rutan, the guy that wears all blue, denim on denim, not a good look. And then that's Peter Diamandis, who's the founder of X Prize, and then Richard Branson, whom you probably know. So this is them celebrating. So they called me last year, and they said, we want you to design for us what the X Prize for healthy buildings should be. Tell us what it should be. We'll give you a budget and a schedule, and we're going to give you 2 grad students and 2 fellows from Deloitte, and that's your team, and you're going to work up what the X Prize for healthy buildings should be. And you're going to be doing this with 8 other teams that are working on other prizes that are equally interesting. There's a prize for cancer and for ALS and for desalinization. And so that's what we did. Over a year's time, these 9 teams, we all worked together to figure this out. They also sent us on a crash course to this other part they have called Singularity University, where they kind of rewired our brains a little bit and taught us how to think exponentially. How do you solve a problem that no one else is solving? And how do you take that solution and digitize it so it can scale to 1 billion people? It was a transformative experience. And it's all kind of written down. You can read about it online. I'm not going to bore you about it. But Peter's book, Abundance, kind of chronicles all this. That the real problem with technology is that we see resources as this scarce thing, as being inaccessible. And this threat of scarcity is what dominates all of our decision-making processes. But in truth, we have an abundance of a lot of things. And that's what we should focus on. So how would you go about doing this? How would you go about starting, solve for healthy buildings, something that nobody else is working on but they should be? Invent the thing that nobody is going to invent but needs to be invented. Where would you start? I'm seriously asking you, where would you, what's the first thing you would do? Nature? Water? Well, the way we started was we really said, well, what do you mean by healthy? So what I'm going to show you is I'm going to show you what we came up with after getting a year to think about this. We then presented this last October at the X Prize Summit. They call their Visioneer Summit. We had to develop little experience rooms. This is our experience room for healthy buildings. It was a pretty trippy space. It had weird Enya music playing and was releasing probiotics, so you felt better the more time you spent in the room, and then had these weird videos, and so it was great. And then their advisors and their boards of directors came through, and then we presented to them. Now, their board, just so you know, is Elon Musk and Larry Page and Dean Kamen, who rode around on that weird wheelchair thing that he invented. And it was a bunch of really weird, brilliant old white men. Basically, it was really kind of interesting. And then this was me presenting it at the summit. And I'm just now realizing how happy I'm not wearing the same outfit. But it could have been close. And there were amazing people in the room, man. There were like wild people. Like you'd meet someone and you go, what do you do? And he's like, I'm the founder of Uber. And I go, oh, the douchebag guy? And he's like, no, the other one. I'm like, oh, nice to meet you. And then like, oh, who are you? I'm the founder of Airbnb. I'm like, oh, okay. Like, and you realize that these people are, like, they're way smarter than I am. There were a lot of celebrities in the room. I didn't know most of them, but the one that I did recognize was Pharrell, and he was dressed impeccably. I mean, he had these like handmade shoes. It was wild. And after he saw my presentation, I said, can I tell everybody that this is your favorite? And he's like, no. And I said, what about your top 3? Can I tell everybody it's in your top 3? He's like, yeah, fine. So then when I got on stage on the final night, I said, hey, everybody, Pharrell says we're in the top 3, so you can all suck it, like that. It was fun. So I'm going to show you, you're in for a long hour. I'm going to show you a little bit of what I presented. And the way it starts is with buildings. Because the way we build buildings is stupid. Think about it. You specify products and materials from all over the planet. We mine it out of the earth, valuable resources. We put them on fossil fuel-based ships and schlep them to the site. When they arrive on the site, they're assembled by hand. Each building is a bespoke prototype. Each building is a one-off. And none of it capitalizes on any of the technologies of the last 200 years. But there's a revolution that's about to occur that's going to transform construction. if green building is a small subset, and this is generous, if green building is a small subset of overall construction, there's a revolution in biology and DNA that could transform how we do this. But if we don't pay attention to it, it's just going to pass us by. So that's really our big idea, to use nature's technology to grow buildings. And we call this process prostruction. Prostruction is the opposite of construction. That's basically it. So this is the prize that we designed. Grow us a wall, 8 feet by 8 feet. Have it match the regular properties of a normal wall, strength, weight, so forth. But add in some of these biological features. Maybe it heals itself. Maybe it glows. Maybe it absorbs VOCs or carbon. You do this in 6 months, and you win $10 million. Real clear, simple, precise. That's what we did. And then a lot of people have asked me, as I've been telling people about this, they said, why a wall? Why a wall? Who knows where ideas come from?
I'm building a wall. We're building a wall. Well, I'm building a wall, okay?
You know, they're in the ether. Who knows? You know, it just comes to you. Inspiration strikes. Now, I studied under students of Frank Lloyd Wright, and Mr. Wright used to call what he called organic architecture. Mr. Wright used to use biological terms to describe his process. He used to say that a building would grow from its site, that it would adapt to its surroundings. And so for 25 years now, I've held on to this promise of organic architecture, of truly organic buildings. One of my other mentors was Malcolm Wells. He's the father of underground building. He said that if we were to scrape a site and build a building, we have a duty, a responsibility to restore the nature in the process. And so this is our chance to do that, because we've been building the same way for 200 years now. And it's just bang it. It's just not a very productive way to use it. And these buildings, they leak, and they're not very thermally efficient. And all of you have gotten very good at, you know, kind of overcoming a lot of these issues and failures. And we build the same way everywhere. So we just kind of crap out these buildings. Whether it's in Arizona or Alaska, we build essentially the same way using the same technology. I'll show you what I mean. This is a building in 1916, and this is today. It's the same technology, literally. I would show you one from 1817, but cameras hadn't been invented yet. Do you see what I'm saying? Like, it's a bit of a problem. You could essentially resurrect a zombie from the Civil War, put him on a job site, and he'll go right to work, and that's amazing. But you know, it's kind of missing out on some opportunities, because we didn't know back then what we know today. We didn't know about asthma or endocrine disruption or workplace productivity or cancer or carcinogens or any of that stuff. So as John Oliver would say, like, how is this still a thing? It doesn't really make any sense. Now, there are trends that you are already aware of, that you know that are going to happen, things that you can expect. We know materials are going to continue to get more and more transparent, more and more revealing in what's in them. They're going to continue to get less and less toxic, less and less bad, but they'll never be good for us. And they'll continue to get better and better sourced. That's been going on for the last 20 years. We also know that building codes themselves are going to get less and less prescriptive, more and more proscriptive, and more focused on performance-based, right? And you've all been dealing with that as well. In fact, in San Francisco, every building has to be LEED Gold or higher if it's a commercial building above 5,000 square feet. So there's, you know, these things are already in place. I didn't need to invent those. They're already happening, and they're happening slowly. We also know that, in general, lobbyists and policymakers are going to continue to drag their feet, block regulation. We tend to only focus on new flashy finishes, of which there's a bunch of healthy ones, but it doesn't solve the underlying problem. So we need a disruption. We need a paradigm shift. We really need a change. I'll show you what I mean. This is a living wall, right? It's beautiful. I've done a lot of these. This is a living roof. We've done a ton of these, but it's nature over a toxic, dead, lifeless structure. It's gross. What if instead the building were actually alive? Literally alive. A building that could breathe, that could process waste, that could heal itself. Imagine the possibility, good snort over there. Imagine the possibilities of what you could do. So I kept asking myself, if a green building isn't enough, what did I want from this? Because for decades, I built buildings like this. Buildings that, frankly, I used to call healthy buildings. But I realized this is not a healthy building. This is a building that won't kill you. That's, I mean, it's a benign building at best, right? That's what it is. But it's not healthy. A healthy building would be like, you rub this and it feeds vitamins into your skin. Or the more time you spend in it, the better you feel. That's a healthy building. So I kept asking myself, if this isn't enough, what do I really want here?
Lies! Lies, do you hear me? Give my creation life!
That's what I want, life, real life, that's what I want. I realize that. So if we're going to grow a wall, we mapped out the whole process that would need to occur to get from that to a whole building. Why are we growing a wall? Because it's the minimum viable product, basically. We even mapped out the steps that would need to occur in between to reach that point. We can't just say grow a house. Nobody will know where to begin. But growing a wall becomes this tangible finish line. We even mapped out the whole process of how it could keep evolving and growing. So it takes a team 2 to 3 years to complete this. Eventually, you'd see other things like the first commercial use. In fact, when we presented this to the Airbnb guys, they said, we want to grow hotel rooms, so let's do that. We saw other things like AutoCAD will make a plugin to really translate between a DNA compiler and your Revit model, essentially. We'd see other cool things like code approval with the ICC and ICBO. Maybe the best-selling Christmas gift that year will be Grow, Barbie's Dream House, right? All the kids will want that. And maybe we'd see other cool things like the US GBC and the World GBC would automatically give equivalency, so any pro-structure building would automatically be LEED Platinum. You'd see other things, the first skyscraper where they build it out of a normal frame, but all the walls, all the infill are pro-struction, and it cuts their time and labor in half. Corn would stop being the #1 crop in this country, and instead we'd grow building materials, which would be kind of cool. And then that would just keep continuing until we grow a full building. That's kind of how it could work. But none of that occurs unless we incentivize that first thing. None of this is going to occur organically or naturally unless we really incentivize this idea of a pro-struction model. So in developing the prize requirements for this, they're very touchy. You don't want to be too restrictive. You don't want to lock people up too much, but you want to make them open-ended enough that people can come up with something. So this is what we came up with. If you're going to grow us a wall, it's got to be strong. It needs to be as strong as, at least as a normal frame wall. And it should have some sort of insulation value, both thermal and acoustic. And it can't weigh too much. If it's super heavy, it wouldn't work with existing buildings. And most importantly, it has to have at least a 1-hour fire rating, or the building inspectors won't even look at it. So grow us a wall, but it has to meet these requirements. And I know you're wondering about other things because you're all nerds, but there's a whole bunch of other requirements I'm not going to share with you, but I can talk to you about it afterwards. Accommodating a chase inside for electrical and plumbing and other water intrusion things. We even mapped out the phases of how you could get this prize, where you might start out first with growing something over some sort of formwork or armature. Then you might grow into where you can essentially manipulate its own structure, the same way that you grew, right? You didn't grow out of a mold, you had a skeleton. And then, or third, it would add in some of these biological features. There's an additional pot of money. And then fourth, if you end up making that compiler between AutoCAD and DNA, which you might do anyway, then that's the full 10 million right there. We even defined the word grow. We had to for the prize, right? So untouched by human or mechanical hands, using nature's technology. And I know a lot of you are thinking plant-based, but actually plants are kind of slow and weak. We think it'll be some hybrid of 2 or 3 of nature's technologies. It might be mushroom, fungus, mycelium mixed with coral, mixed with something else, bacteria, who knows? That's up to the teams. And I know this sounds trippy and science fiction-y, but it's actually possible now. There have been architects that have been working on this for 20 years. And this is the paradigm shift we've been looking for. Because only in construction do we have these global supply chains where we move things all over the planet. In pro-struction, everything would be sourced locally. In construction, we use CO2 as a waste product. Pro-struction would use it as a building block. And in construction, we build the same way everywhere. In pro-struction, we can adapt to the surroundings of each individual unique site or climate. And only in construction do we consume and consume and consume and consume to the point of excess. In pro-struction, everything could limit growth, reach equilibrium, the same way nature does. What's driving all this is, for the first time ever in human history, we know now why a zebra gets its stripes. We know how a leaf heals itself. We know why the firefly glows. And what's making it all possible is DNA. Just one of these innovations could transform how we build it. Think about your own arm, how it thickens at the point of higher stress and thins out in the middle. All out of a material that's 4 times the strength of concrete. And half the weight, by the way. It's amazing. Just one innovation like that could transform how we build our buildings and move us from this weird thing of putting little pieces together all the time into growing everything all at once. When you were born, you didn't come out a skeleton, and then they had to wait for the muscle inspector to come, right? And then they put the muscles in, and then they had to wait for the tissue inspector, and that's not how it works. So we could suddenly shift it from mass production to mass customization quite easily. Instead of painting walls, the pigment could come from within. We wouldn't need light fixtures anymore because the whole surface could glow the same way that nature does. Every building could be a LEED Platinum building. Every building could be a Living Building Challenge building by default. Every surface could be a smoke detector and sense chemicals. And when you remove a picture hook out of the wall, it could heal the same way your own skin does. You could even change the color based on your mood or the holiday. Like hey, it's Halloween, let's make the walls orange. Like you could have a little fun with it. You could even light your way home with the trees instead of streetlights. It's all possible. Every surface could absorb VOCs or CO2 or any other chemical that you want because nature already knows how to do that. And it's very much designed to work with existing buildings. Otherwise, it's not really any good. So, put in your, grow your shell and then put in your IKEA cabinets or whatever you want to do there, right? I did a kitchen once. The client spent $350 grand on the kitchen. 10 years later, they ripped it out and built a new one. That's what clients do. So grow the shell and everything else can be temporary. We could even use this to repurpose the old buildings and use it as a formwork for the new. We could even do other cool things and grow the way nature does. The way bees orient their hives to north, we could do the same thing with our buildings. We could even bake the building code itself into what we grow. So if we grew a stair, it would automatically have 8-inch risers. Think about it. You wouldn't need building inspectors anymore. And nobody's going to miss them, believe me. And any mistakes you make on the site just get thrown back and composted to grow the next batch. There is no waste. So this whole thing could really reverse desertification in that narrow band on the planet where most of us tend to live. And this is very much designed to grow and evolve and adapt over time. So grow your building, reaches stasis, and then it could grow more if you need it. Imagine every surface, a battery, a sensor, a heat sink. It's all possible. So let's grow our buildings. Let's change this paradigm from cut, slash, and burn for the last 200 years to grow, regenerate, and breathe. This is not a new idea. This has been discussed openly for the last 20 years in a field called synthetic biology. And the trends are clear. For a long time, we had low-emitting materials. All of you have used those. And then zero-emitting materials like paints and adhesives. Those are commonplace. You buy them at Lowe's or Home Depot now, essentially. Then we have agricultural waste-based products. They're about to take off. The next big one are bio-based products. Right now, it's a $65 billion a year market. It's going to be $2 trillion in the next 10 years. And if you look at this trend, you see how they stack up. You can see the next logical thing are going to be living materials. It's kind of clear where we're headed. DARPA, which is the research arm of the US military, they're the guys that invented the internet. You remember them? Last year, they had an RFP for engineered living materials. They want you to grow drywall, essentially. So this is already happening. It's already underway. So our idea really just pulls together all of these disparate little elements into one cohesive whole. And what's really driving this is, for the first time ever, human beings can easily and cheaply replicate, copy, and edit DNA, and the cost of which just keeps plummeting, just keeps getting cheaper and cheaper, using a technology that we call CRISPR.
CRISPR is a molecular scalpel that we can program to cut any DNA sequence of interest. CRISPR is one of the tools that is making biology become the new digital.
Biology is the new digital is what's key. We essentially drag and drop bits of DNA the way we drag and drop computer files or MP3s. And by the way, if you're wondering what CRISPR stands for, don't. It's a world's worst acronym. It's like, it'll give you a headache just to think about it. But it's all part of this burgeoning field called synthetic biology. And so what we did was I looked up the 20 leading synthetic biologists in the world, and I contacted them. And so I contacted Stanford, MIT, and Harvard and met with all of them. If you look at the MIT synthetic biology website, growing a house is on their to-do list. They've been talking about it for a while. So I went to MIT and visited with their synthetic biology lab. I met Ron Weiss, Professor Ron Weiss from the Ron Weiss lab. This is his office, by the way. Here's how smart he is. That's his lunch order. Do you see what I mean? Like, the guy's on a whole other level than you and me. And I told him about what we wanted to do, and I said, is this nuts? And I said, what if I wanted a wall that heals itself? He said, oh, that's easy. I said, what if I wanted it to glow? Yeah, that's easy. What if I wanted to change color? Easy. And I started to get rather uneasy with his use of the word easy, because that's not a very scientific term. It's kind of a nutsy term. I said, what do you mean by easy? He said, we've already identified how nature does all of these things. We just drag and drop them like software packages, basically. I said, okay, if all that's easy, what's hard? And he said, well, buildings are big, and we have trouble with big things. I said, what do you mean? And he pulls out his phone, and he's like, see this? Yesterday, I grew a liver. I said, excuse me? He said, yeah, it was pretty cool. I took skin cells from the back of my hand. I programmed those to be stem cells, which is easy, by the way, and then commanded those to be a liver. Are you telling me you cloned your friggin' liver yesterday? Is that what you're telling me? He's like, oh, no, it's not a clone. This is a better liver. Like, this liver is so much better than my liver. I said, what is it? Like, play the piano or something? What do you mean? He said, this liver does all these things I can't do. Like, if it detects chemicals for cirrhosis, it alerts us. And I said, what is it, sending you a text message? Like, what do you mean? He said, no, it releases a chemical that alerts us. It changes color, essentially. And I said, so you're essentially growing livers, and I'm Schmucky the architect. Am I totally getting in the way here of what you're trying to, you're like going to save lives and stuff. He said, well, the liver that we grew is only this big. We're having trouble, we're stuck growing a full-size liver. He said, if you can figure out how to grow things big, that would really solve a problem for us. And so then we realized this is not an X Prize about growing a wall, it's really an X Prize about growing something large. The way that biologists do it now is they use what's called a scaffold. This is a scaffold. This is a coconut husk. An apple is mostly scaffold with apple DNA in it. You are a scaffold. You're a walking scaffold. You're a skeleton draped with meat, right? That's basically what we are. The scaffolds they use now are small. They're medical grade. They're expensive. They're sterile. When I think of scaffold like you, I think of this. And that's basically what it is. It's you grow something over this. So that's what we're going to do. And nature has thousands of ways that it grows scaffolding organically. I also asked Professor Weiss, I said, how do we make sure, that we don't get, I don't know, Jurassic Park from happening? Like, how do we just prevent that? And he said, well, first of all, your building's not going to chase you through a kitchen. And if it does try to eat you, it'll do it really slowly. And I said, is that biologist humor? And he said, yes. So there you go. So if you're sitting there like scowling, like, oh, he's going to create Swamp Thing and kill us all, it's like apparently not going to happen. It's not going to happen. We are now at a weird point in our development as designers because I can design things that I can't build. I don't know if any of you have reached this. But I'm able to generate geometries on the computer that I can 3D print small, but I can't build them. So we have 3D printers capable of producing geometries like this, but our buildings still look like this. We have electric vehicles capable of running hundreds of miles on a single charge, but our buildings still look like this. We have 3D digitizing scanners that can capture a room instantly in real time, so we can manipulate it. But yet our buildings still look like this. We even have a little app that tells you when the hot donuts are ready. That's impressive. But the donut shop still looks like this. Every major technology is advanced except our buildings. So we need a disruption. We need a change. We need a chance to look at beautiful old buildings like this and restore them. We need to be able to look at old infrastructure and step back and question it and say, is this really necessary? We need to look at building codes in a new way and realize that they too need to be disrupted. Does anybody see what's wrong with this photo? So this is in Belvedere, California. This is across from San Francisco. And the building inspector said, oh, you have a railing, so it needs to be 3'6". I said, for who? And he said, well, it's, the code. It's 3'6". There's no door. There's no door there. So it's a railing for nobody, essentially, for when Spider-Man comes over. I'm not quite sure. So that's part of the problem. We've paved over paradise and put up parking lots everywhere and undone our ecosystems in the process. And some buildings are so evil and so insidious, you don't see it right away, but it's there. It's there. You just got to pay attention to it. And on top of that, by the way, I don't know if you realize this, we're not very well liked. People hate architects and builders. Everybody's got a story about it. They even made a commercial about it.
You're working hard, you know that it's true. You need a brand new soap that works hard too. You are the worst architect in the world.
I like the tile work at the end. That's my favorite. If you don't believe me, Google it. You'll see what people really think of us. These are not fake. This is just autofill for Google. They hate us. Everybody's got a, oh, my architect or contractor screwed me story. All I get are wave after wave of antipathy from people. Go, I hate architects. Oh, nice to meet you. Okay. It's strange. By the way, you can learn a lot from Googling things. If you want to kill an afternoon, just start typing stuff in. You'll see what I mean. I didn't know you could accidentally kill your sister. I didn't know that was a thing. Where was I? Oh, so the way we build is stupid. I mean, it doesn't make any sense. What are we holding on to here? Buildings are not great. We're surrounded by failure. And what's worse is we spend 80 to 90% of our time indoors. We never go outside. I mean, granted, this guy spends 100%. But we spend a lot of time indoors. And this is just going to continue until finally, it's just going to get worse. We're just going to be plugged in. And when we do go outside, it's always, it's always scheduled. Like, I got to get a hike in. Like people put it on their calendar. It's weird to me. And some people, when they go outside, they can't control themselves and they go nuts. Like they're all built up or something. And the indoor air is awful. It's really, not that the outdoor air is that great either, but the indoor air is toxic. So we can solve for energy. We can solve for, even water, but I can't solve anything if we toxify the whole planet. And buildings are the problem. They're gross. They're disgusting. And we build them outside in the rain where it's, mold happens and stuff. It's not. And by the way, job sites are horrible places to be. They're incredibly dangerous places. I once stepped through a nail that went through my shoe, through my foot, and out the top of the shoe. That'll ruin your day. You know what I mean? It's like, it's not a good place to be. And buildings are routinely over budget and over schedule. It's like commonplace, essentially. And where worker productivity has gone up in every other industry, in construction it's gone down because we're using 200-year-old technology. So productivity goes down and costs keep going up. It's a terrible business model, as you're finding out. And because of this, our margins for actually researching innovation or sustainability keep shrinking. So you don't have time to do what's right. And so you kind of fit it in, or you do it in your free time, or you make an intern do it. It doesn't really make sense. And these materials are coming from further and further away. And now their costs keep going up. So we are doomed. We just don't realize it yet. This 200-year-old model is going to come to an end whether you like it or not. We're also the only industry that has a 37% waste factor. Do you realize that? Every time we build a building, we take a third of it and throw it away. Imagine if every time Apple built an iPhone, it had a third of an iPhone that it threw away. It wouldn't be in business very long. And yet buildings are what must change. Buildings are what need to change because they're the source of all these carbon emissions. So if we want to solve the climate crisis, we have to transform our buildings. And making little incremental buildings is not going to do it. So pick your market failure, whatever you want, whether it's labor, waste, climate, materials, it doesn't matter. Across the board, we are failing as an industry. And on top of that, buildings are not very comfortable. Like, they're very awkward. They have these weird corners and we bump our elbows. Like, we're built in these beautiful curves, right? I mean, some of you more than others, but still, we're built in these gorgeous curves, and buildings are not. They're hard and itchy, it's like not a good place to be. What we're really talking about here is indoor air quality. And when I'm talking about indoor air quality, I'm not talking about, Derek in the cubicle next door to me. I'm talking about that known phthalates, known endocrine disruptors that are absorbing through babies' little pudgy hands and pudgy knees. I'm talking about that new car smell every time we paint a room. That's what I'm talking about. Known carcinogens. And it's making the indoor air 10 times more polluted than the outside air. All of you, on average, have about 17,000 known cancer-causing chemicals in your home right now, waiting for you for when you get home. And if you look at the sources of indoor air quality, 9 out of 11 are controlled by building materials. Because you can choose not to smoke, and you can choose not to have a cat. And by the way, you should totally choose not to have a cat. Cats are weird, and they stare at you, and they're gross, and they poop in a box. It's strange. Don't have a cat is basically my underlying thesis here. So we need healthy buildings. We need them now more than ever, especially because over the last 40 years, we've learned how they're linked to a whole host of diseases, everything from neurological to terminal disease. And we're just making ourselves sicker and sicker. And what's worse is we're passing this on to our children. Through a process of bioaccumulation, we're essentially giving toxins to our newborns. The average breast milk has about 500 known carcinogens in it. There's about 300 known carcinogens in umbilical cord blood. It's bad, including PCBs, mercury, lead, and arsenic. And we still don't know how all these things mix together. When you go to a restaurant, you assume there's a social contract. You assume the waiter's washed his hands. You assume the plates are clean. Everything on the plate is edible, including the garnish. You assume that the silverware has been cleaned. But there is no contract like that in buildings. You can put anything you want into a building, except asbestos or lead paint, anything you want, and that's fine. There are no laws governing them. And in California, they require you to put up a sign. But I took this picture off of a school. It's not like the kids have a choice not to go in there, right? They're like, no, I'm not going to go today. Like, you have to go. So I would also argue that environmentalism has failed. That 40 years of a modern environmental movement, and we've ended up in the exact place that we were trying to avoid in the first place. And that's probably the worst part of all. Now, I'm an environmentalist. My friends are environmentalists. And I'll be the first one to tell you that we are part of the problem because we're annoying. You have environmentalist friends. They're annoying. Sometimes you think the only answer environmentalists are going to accept is this one. And this one doesn't work for me. I don't know about you, but this is not what we call scalable. Do you see what I'm saying? But there's virtually no solution here. There's no research and development in the building industry. It's practically non-existent. So how is this going to solve itself? It's not. No candle manufacturer invented the light bulb. That didn't happen. The post office did not create email. That's not where innovation comes from. Innovation doesn't come from inside the industry. It comes from without. If we want to transform the construction industry, we need to be inspired by other fields. And nature knows how to build things. Nature knows how to build them quickly, rapidly, and in a resilient way. We are not the first creatures to build on this planet. There are lots of creature contractors all over the place that build all sorts of things every day. This is the paper wasp. It builds its nest in a matter of days. It takes wood pulp from local trees, mixes it with saliva, and makes a form of cement. It can change the hydrology of the cement based on the humidity in the air. This is the weaver bird. It builds its nest in a matter of hours. It takes local grasses from around the site, uses its own body as a tape measure, and makes this cool tripod shape. It makes the opening just big enough so the weaver bird gets in, but none of its predators. It's amazing. This is the silk henge spider. It protects its eggs by building a fence around the nest. Equally spaced, mind you. It's incredible. This little beauty, this is the bagworm moth. It stacks little bits of logs to make a pyramid, which its young then eat as it's born. And then my favorite, this is the Japanese pufferfish. This little beauty knows that he's not a good-looking guy. He knows that. So what he does to attract a mate is he paints the bottom of the ocean. He digs on the bottom of the ocean to create a pattern to attract the mate. It's incredible. I got to speed up the video, but when it zooms out, you'll see what I mean. There we go. And this, you feel seduced now? This is what it does to attract a mate. So that's what I mean when I say that I got tired of, oh, another LEED Gold building, yay. Like, it was just hard to get excited about that anymore. Designing Barbie's net zero energy dream house is not going to solve our problem. It's only going to delay the inevitable. What are you holding on to here? We're not very good at this. In fact, we downright stink at it, really. Sometimes it's just humorous, and sometimes it's catastrophic, but the way we build our buildings is stupid. We make huge mistakes. By the way, nature's builders make mistakes too. I don't want to get, their little contractors make mistakes, but not like us. I mean, even nature makes mistakes. Nature makes weird, mutated, gross mistakes all the time. So what if we combine the best of both worlds? What if we kind of, our ingenuity with nature's technology? Maybe that's the best of both worlds. And we could really, on the evolutionary chain, really be onto something. Because mankind has cool things that I love. Like, I love my Dyson vacuum. Sometimes I just hold it. I love it so much. By the way, you should totally get one. They're awesome. Or I love those little, the pore strips with the nose. I love to peel that off and just leave it on my wife's nightstand. Part of that torture thing I told you about. Or the fact that we invented this. Those are pretzel roll. That's just not normal wieners in the blanket. Those are pretzel roll hot dog. That's amazing. In 1980, my old mentor, Malcolm Wells, sketched this. He did it almost as a joke. But this is kind of what we're talking about here, growing a building. Every few years, Wired Magazine recycles this joke of seed packet buildings where we grow a building. But this is out now actually a reality. There are architects working on this. This is Mitchell Joachim. He's using pleaching, essentially bending live trees and growing structure in between. This is Vincent Cabot of growing buildings. This is David Benjamin in New York, where he used mushroom-grown bricks. Those are bricks that grew from fungus that were placed by a robot into a structure. This is Neri Oxman at MIT. She trained silkworms to build what she wanted. They were her contractors. This field of synthetic biology is a growing market. It was $600 million just a few years ago, and it's going to be billions in the next couple years. And so while these synthetic biologists are trying to grow designer pets or whatever the hell they're doing, we're just trying to grow buildings. I mean, and it's becoming this perfect stepping stone to what they're doing. One of the biologists said to me, is it okay if we're off by a few inches? And I'm like, yeah, we're off by inches all the time. Like, we're off all the time. Like, and then I kind of pulled back a little bit. I didn't mean to say that. But yeah, we can be off by, like, we'll just shim it, we'll just deal with it. So this idea of growing buildings becomes this perfect stepping stone, not just to build healthy, abundant buildings for everybody, but for all these other biological uses that we're talking about. In the process of building this, we also partnered with some incredible folks. In fact, some of you might recognize some of your logos up there. We also got great partnerships. The UL folks agreed to donate testing services to all the teams for free, so they could do the load testing and fire testing. Autodesk gave us access to their digital fabrication studios in San Francisco and Boston. And then Lacey gave us their lab testing space in LA for the teams. All told, it's about $2 million worth of free stuff that they gave us, which is kind of cool. We also partnered with the Biomimicry Institute and the Building Green folks. They're providing go-to-market support for all the teams. Ecovative, who are growing mushroom-based bricks, they donated bricks for the displays inside the room, and they're kind of coming on board as advisors. We even reached out to Apple and said, wouldn't it be great if my Apple Watch measured how much time I spend outside every day? And Apple wrote back and said, yeah, we'll look into it, which for Apple's huge. Like, normally they just ignore you. So we were very excited about that, a one-line email. And let's see, Harvard's Graduate School of Design is providing computational design support. I don't even know what that means, but that kind of still is impressive. Interface Carpet wants to be the first company to grow a carpet. So they've come on board to help with that. And then the BioBricks Foundation gave us their open source licensing agreement for free for all their teams. So basically, whatever the team creates is open sourced to everybody. And then in the course of that, we created this design competition with our friends at Inhabitat. And we asked people to show us what prostruction could look like. And we received hundreds of entries from 14 countries. And they're incredible. I'm just showing you a few, but you can get the rest online. And they're, some of them fairly traditional, some pretty wild, hobbity type things. But it's pretty cool. That's the power of using nature as a technology. That's the power of putting in our mindset that our current paradigm is broken and we need to change it. That's the power of really realizing that this is an ultimate opportunity for us, of seeing nature as a technology. You've heard of better living through chemistry. This is better living through biology. And instead of our buildings making us sick, we could save the 7 million people a year that die from toxins exposures caused from being inside buildings. So let's grow our buildings. Let's grow healthy, beautiful, abundant, organic buildings. Or as our president said it best.
And I said, we need to build a wall. And it has to be built quickly.
Quickly, hear that? Quickly, let's go, quickly, let's go. Grow us a wall, 8 feet by 8 feet. Have it match the regular properties of a wall, but add in these biological features. Do this in 6 months, win 10 million. That's awesome. If we build this prize, if we launch this, if we make this actually happen, we're essentially launching a future of abundant, cheap, affordable, healthy homes all over the planet for everybody. And to me, that's the pot of gold at the end of the rainbow. Really, that's kind of the prize. That's what I would define as victory for the 21st century. Thank you all so much for coming. Thank you all for doing this.
Wow. Everybody's eyes open now. We're going to take a few questions for Eric. Anyone want to be the first? Anyone? Anyone?
I stunned them.
Oh, there we go.
So given CRISPR's first commercial application, the produce, creating these, better tomatoes, better apples, and seeing the fear that caused in the public, what do you envision the response is going to be to now these buildings and walls instead of just, a tomato in a fridge?
I'm so glad you asked that. So basically, we're manipulating DNA to grow food. So the idea is you could grow a tomato this big and like whatever else you want, and that freaks people. It freaks me out. It freaks everybody out. Who wants to eat that? But you're not going to eat these buildings. So what we've realized is that this could also get people accustomed or comfortable or accustomed to dealing with, essentially synthetic biology. This could become a gateway drug, if you will, where they'll grow a wall and they, they'll touch it, but they don't eat it. They don't put it in their body. At least they shouldn't. And over time they'll get used to then growing produce. And so otherwise it just, you're involved with the Food and Drug Administration and GMOs and all that battle and everything else. And so we avoid all that by saying, well, we're not edible, we're not sterile, we're just a building. And so we talked very extensively about that, actually.
Next.
I should, while Kathy's running a lap. So the last slide that I showed at the summit was this one. The prize development had been sponsored by Lowe's, the hardware people. But I had to call them and say, do you want to sponsor the whole prize? And so I scheduled it with them. And on the calendar invite, it said money call is what I put it as, because I didn't know what else to put it. And then when I was on the phone with them, I said, so this is what we're thinking for the prize, and we're thinking the prize would be $10 million. Would you sponsor it? He's like, yeah. I said, I don't know if you heard me. It's 10 million with an M. Like, it's not 10,000, it's 10 million. He's like, yeah, I heard. I said, are you sure? It's a lot of money. And he laughed at me. He's like, dude, we're a $60 billion a year company. We make that in about 23 minutes. I'm like, oh, so you're okay then? It's fine? So they stepped up to offer the prize, which was nice, too.
I have a question. So when we design that wall and build these buildings, how are they going to preserve themselves? How long this mushroom brick actually lasts? Like if it is organic, it probably doesn't have a long span.
Well, so in the prize requirements, we said that it has to achieve stasis. And nature has lots of ways of doing that. Like, for instance, I stopped growing at 17, but I'm still living. I wish I didn't stop growing, but I did. So nature has one way of doing stasis, but it has other ways too. And so we define different opportunities for that. Maybe the thing grows and then dies and then just, essentially pasteurizes itself. Maybe it dies and fossilizes. Or maybe it does keep living and still requires some inputs. We didn't dictate what that should be. We just kind of outlined that it needs to be addressed in some way. Remember, this is a minimum viable product. It's not supposed to be a packaged solution. So anytime, we did this thing called red teaming. I don't know if you're familiar with this, where we play the skeptic and just try to pick apart the idea, pick apart everything. And so we went through that process multiple times to then say, what could go wrong? What could go right? What other problems are we creating in the process? And so we outlined a number of them, but realized that there's a certain point, it's not like we're delivering Prostruction to you tomorrow that you're going to start putting into your projects tomorrow. We're really just trying to veer the train track a little bit so we go down a different path. And we expect that people will do a hybrid for decades, possibly, where they go, yeah, it's still 75% construction, 25% Prostruction. We figure in 5 years it will be 50% Prostruction. Like, we expect people to talk about it in that way. But it's not going to be perfect, and of course it'll have problems. But when I see all the things that we deal with buildings, with mold and leaking and energy loss and everything else, and we make excuses for that, I realize no technology is going to be perfect. So let's just start this and see where it goes.
Right here.
So what are the specifics of this wall, 8-foot wall that you need? Is it something
you must be an engineer.
Yes, I am, and I want to know where I can pick up my $10 million. It would be a bamboo wall.
A bamboo wall?
Yes.
The bamboo wall wouldn't meet the permeability requirements, but it would certainly get the strength.
It would make Mr. Trump
speed.
happy. you would
We
build
taught, so we ran what we call the hedge test. Like, what's to stop people from just growing a thick hedge and saying, yeah, all right, give me my 10 million. And so there are requirements in there that back that up a little bit, you know. But I like what you're thinking.
Okay. So if you tell me what the requirements are,
Oh,
for $10 million, you know, I can come.
anybody wants to know, I'll send you the full packet that we developed. Just give me a card. That's the easiest way to do it.
Is there a website that has?
Yeah, there's. I bought every Prostruction domain there is, so there's a bunch of them.
Life. Another question.
Do you have teams forming that you're aware of that are planning to submit, or where is it? Where is the?
So right now, well, it's a long story. So right now, we're in what's called a road mapping phase with the X Prize folks. So we're mapping out what are all the housing prizes that we need to do. There's an affordable housing X Prize, for instance. There's a refugee housing X Prize. There's all these other housing X Prizes, including our healthy one. We're figuring out how they overlap and how they work together, and then they'll be launched in a series next year. And then if any of you are going to the Greenbuild conference in November, there's actually a housing forum on it that you can attend on that Monday before Greenbuild. And if you're interested, give me a card and I'll invite you.
All right, any other questions?
Hi, I'm an architect, and you're an architect. As you presented, it's a wonderful idea. But if the buildings can be grown from now on, where do you see us as architects or even contractors in like 10 years or 20 years? Should we all quit our jobs now and just to learn computer science so we can program them later?
No, not at all. This is not designed to put architects and contractors out of work at all. I mean, that would be kind of cutting off my own nose despite my face. No, we still need design inspiration. The difference is instead of doing it out of little sticks of wood every 16 inches, you would do it out of a different technology. This is something you might have experienced if you've ever built a non-frame building, if you've ever built out of rammed earth, pumice-crete, adobe, straw bale, hempcrete, or any of those other fun things. You start to realize this is just the technology, and like any technology, it has strengths and weaknesses and limitations, and you design to that technology, but it still needs someone to design it. I still need your creativity and input and vision. You're just going to use a different tool. And so we imagine there would be some sort of compiler between your AutoCAD or Revit model and this DNA CRISPR machine. You would essentially program it to do what you want. If you've been involved with parametric design at all, where we're using essentially math to come up with results, it's that same kind of feeling where we're moving these little sliders around to see kind of, oh, how does it look, how does it work, and then running tests on it. I imagine you'll do the same thing with this. Just the difference is instead of it being 3D printed, it would be grown. So it's in one sense, it's a very different future than our current reality. But in another sense, it's not that different. For years, we've been told that any day now we're going to get, you know, the Minority Report interface, where I'll be able to like move buildings around on Revit and all that, you know, and wear goggles and stuff. And it's just, it's slowly been happening. I think this will be kind of the same thing. It'll be another technology, but it won't be so drastic. It'll be something that we slowly integrate into what we do. But no, I'm not